Today, we're going to discuss about implicit differentiations. So, here are the guidelines for implicit differentiation. Number one, differentiate both sides of the equation with respect to x. Number two, collect all terms involving dy over dx or y prime on the left side of the equation and move all other terms to the right side of the equation. Number three, factor dy over dx or y prime out of the left side of the equation. And step number four, solve for dy over dx or y prime. So I have here the example. Find y prime given the equation y to the fifth power plus y plus x is equal to 0. So solving for this, we have here, I will write the equation here again, y to the fifth power plus y plus x is equal to 0. Now, the first term is y to the fifth power. We're going to use the power rule. So we can write now 5y to the fourth power. And then every time we take the derivative of y, then we are going to take the chain rule for that. So derivative of y now is equal to y prime. Or you can write also as dy over dx. Plus the second term, the derivative of y is just equal to 1. And since that is y, then you have to take the derivative of that as y prime plus the derivative of x is just equal to 1. So I have said you will only affect or you write the y prime every time we take the derivative of y. But since this is x, so just take the derivative of x which only equals to 1. And the right side now which is equal to 0 because derivative of 0 is also equal to 0. Now I'm going to transpose the other terms that is not having y prime. So in other words, I'm going to write here as 5y to the fourth power y prime plus 1 times y prime is just equal to y prime is equal to negative 1 because 0 then transpose positive 1 it becomes negative 1. That's why negative 1. So from here on the left hand side, I'm going to factor out now the y prime, or if you like, you can write dy over dx. So factoring out the y prime, so we have now y prime times 5y to the fourth power plus 1. Because y prime divided by y prime is equal to 1, and the first term is 5y to the fourth power of y prime divided by y prime, so cancel y prime. That's why we have 5y to the fourth power. So is equal now to negative 1. Now to solve for y prime, so we're just going to divide. So y prime is equal to negative 1 over 5y to the fourth power plus 1. So this is now the answer for that problem. So next number we have find dy over dx given the equation of y cubed minus y squared x plus x squared minus 1 is equal to 0. I will write again y cubed minus y squared x plus x squared minus 1 is equal to 0. So we have here the first term, the derivative of y cubed becomes 3y squared. Since we are taking the derivative of y, then we are going to write here dy over dx. So I'm using dy over dx because we have here dy over dx. Or if you like, you can still use y prime. Now, the second term, I have negative y squared x. So we are going to use the product rule. So the product rule for that, we have to use the formula of u dv plus v du. So our u there is y squared times the derivative of x is just 1 plus v du. We have x now is, our v is x. And the derivative of y squared is 2y. Since this is y, We are every time we take the derivative y, then we are going to write here dy over dx plus the third term plus the third term is x squared. So the derivative of x squared is just equal to 2x, and derivative of negative 1 is 0, so no need to write 0, then is equal to 0. Then I will simplify inside the bracket, so I can write now as 3y squared of dy over dx minus y squared times 1 times negative outside becomes now y squared, and x times 2y of dy over dx times negative outside, it becomes now negative 2xy of dy over dx plus the next term is 2x is equal to 0. Now, I'm going to combine the having dy over dx. So and I will write that one in the left hand side. So we can write now as dy over dx is our common factor between the two terms that I have shaded into yellow times we have 3y squared minus 2xy is equal to that the other terms we're going to transpose to the right hand side. So from negative y squared, it becomes now positive y squared, and negative 2xy dy over dx will remain here on the left hand side. So the other term, which is now positive 2x, so it becomes now negative 2x. Since the right hand side there is 0, then right hand side will be just equal to y squared minus 2x. Or you can write in this way if you like. We have 3y squared minus 2xy of dy over dx. So they are just the same with the with this solution here above and this one below. They are just the same. So we have the right side now is y squared minus 2x. So in order for us to solve for dx over dy, then we have to divide both sides by this quantity of 3y squared minus 2xy. So therefore, from here, we can write now our dy over dx is equal to y squared minus 2x all over 3y squared minus 2xy. And that will be our final answer. Question number 3 is that given the equation x squared plus y squared equals 4. So we have to find letter A, find dy over dx by implicit differentiation. And letter B, we are going to find the slope of the tangent line to the curve at the point square root of 3, 1. And letter C, we find the equation of the tangent line at that point. So first, we're going to solve dy over dx using implicit differentiation. So for letter A, we have here x squared plus y squared is equal to 4. So taking the derivative of that using implicit differentiation, so we can write derivative of x squared is 2x plus the derivative of y squared becomes 2y using power rule, and the derivative of y is dy over dx is equal to 0 because the derivative of 4 is 0. Then solving now for dy over dx, so I will transpose the other terms to the left hand side. So we can write 2y of dy over dx is equal to 0 minus 2x is just equal to negative 2x. And then solving only for dy over dx, then we have to divide both sides by 2y. So that's why we have now dy over dx is equal to negative 2x over 2y, or we can simplify it further because the coefficients are the same of negative 2 and positive 2. Therefore, dy over dx is just equal to negative x over y. So this is now the derivative of the given equation by using the implicit differentiation. Now for letter B, we are asked to find the slope of tangent line to the curve at the point square root of 3, 1. So we know that the slope of the tangent line is equivalent to the first derivative, which is now equal to the negative of x over y. So for letter B, we have m is equal to dy over dx, or that is now equivalent to m is equal to the value that we have solved is negative xy. Now, from that point, we know that in the given ordered pair, so this the square root of 3 is for the value of x, and the value of y is equal to 1. So we have the slope now is equal to negative square root of 3 over 1, or simplifying that one, we have negative square root of 3 divided by 1 is just equal to the negative square root of 3. So that is now the slope of the tangent line. Now, to solve for letter C, since we are asked here to find the equation of the tangent line at this point, so we have we are going to use the slope intercept form. We have y minus y sub 1 is equal to m times x minus x sub 1. So our x1, y1 is actually equivalent to the square root of 3 and 1, wherein the slope of the tangent line is the one that we solve here is equal to the negative square root of 3. So using this data in order for us to solve for the equation of the line. So we can write now as we have y, our y sub 1 is positive 1 is equal to m is negative square root of 3 times x minus the value of x sub 1 is the square root of 3. So multiplying that one, so we can write now y minus 1 is equal to the negative square root of 3 of x. And then we have negative square root of 3 times negative square root of 3 is just equal to positive 3. Negative times negative is positive, and square root of 3 times square root of 3 is just equal to 3. And then we are going to transpose, and we have here y, then negative square root of 3 becomes positive square root of 3 of x is equal to 3 plus 1 is equal to 4. Or you can also write, equate that one to 0. We have y plus the square root of 3 of x minus 4. So either of the two answers are accepted. So you can write as this or the other, this one. And that is now equal to 0. I forgot the 0 is equal to 0. So your answer is either y plus square root of 3 of x is equal to 4, or y plus square root of 3 my square root of 3 of x minus 4 equals 0. So next problem is find the derivative with respect to x of the implicit function of the square root of x squared plus y squared as the first term plus x squared equals 2. We have the square root of x squared plus y squared plus the second term is x squared equals 2. So taking the derivative of that, so this will be now, you need to rewrite this one in terms of fractional exponent, or you can solve it mentally that it is already in the form of fractional exponent. So therefore, we have 1 half times x squared plus y squared to the power of negative 1 half times the derivative of the base, because we are using here the chain rule. Derivative of x squared equals 2x plus the derivative of y squared is 2y of y prime. Okay, and then the second term, we have derivative of x squared is 2x is equal to the derivative of 2 is equal to 0. Now multiplying this one, Okay, so we can write now as we have 2x plus 2y of y prime over 2 square root of x squared plus y squared. Because x squared, the quantity of x squared plus y squared to the power of negative 1 half, it can be written as the square root of x squared plus y squared. So I write here 2 as the coefficient of the radical because we have 1 half here. And then the second term will be positive 2x is equal to 0. Now our problem is how can we solve now y prime? So in that case, we need to take first the LCD of the two terms. So we know that the LCD now, or we can just multiply the entire equation by 2 square root of x squared plus y squared. So multiplying the entire equation by 2 times the square root of x squared plus y squared. So multiplying that one, so this one will be cancelled. So the answer now will be the numerator itself, which is now 2x plus 2y of y prime plus we have 2x times that will become now 2x times 2 squared of x squared plus y squared. It gives us the answer of 4x of the square root of x squared plus y squared is equal to 0 because this one, the LCM, multiplied by 0 is just equal to 0. Now, we can transpose or isolate that having the y prime. So we are going to isolate this one. So the other terms will be transposed to the other side. So we have here 2y of y prime equals, we have to write a negative 2x minus 4x the square root of x squared plus y squared. And then we can divide both sides by 2y to solve for y prime. So therefore, y prime is equal to negative of 2x minus 4x square root of x squared plus y squared all over 2y. Or you can also write here as y prime is equal, if I'm going to factor out here negative 2x because negative 2x is a common factor to the numerator. So I can write now as negative 2x times we have 1 plus 2 square root of x squared plus y squared all over 2y. Again, let us check. Negative 2x times 1 is negative 2x. And negative 2x times positive 2 square root of x squared plus y squared is equal to negative 4x of square root of x squared plus y squared. Now, we could see that there is uh, something to be cancelled, which is the 2. So therefore, we can simplify it further. We have now y prime is equal to the negative of x times 1 plus 2 square root of x squared plus y squared all over y. Okay, so that will be now our final answer. Or if you like, you can also write your answer as negative x negative 2x of the square root of x squared plus y squared all over y. So in this case, at this point here, we can already reduce here the coefficients of negative 4x with the 2 and also negative 2x over 2y. We can also cancel that one. But anyway, I already shown it here how it was done. But it's okay if you're going to stop your answer up to this point, or you can stop your answer up to this point. Okay, so next, we have determine the slope of the graph of three times the quantity of 3 times the quantity of x squared plus y squared to the power of 2 is equal to 100 xy at the point 3, 1. So we're talking here about the slope of the equation. So to find for that, so we're going to solve first uh, the derivative using implicit differentiation. So we have here 3 times the quantity of x squared plus y squared to the power of 2 is equal to 100 x y. So taking the derivative of that, 2 times 3 using power rule, we have now 6 times x squared plus y squared to the power of 1. No need to write 1. And then take the derivative of this using chain rule, times derivative of x squared is 2x plus derivative of y squared is 2y, but this is implicit differentiation. Therefore, we have here y prime after taking the derivative of y squared is equal to 100 times, using the product rule, we have x times derivative of y is y prime plus y times the derivative of x is just equal to 1. So simplifying this one, I can write now 6 times, I will just copy this on the left hand side. So 6 times the quantity of x squared plus y squared times the quantity of 2x plus 2y y prime is equal to, we have 100 times xy prime plus y, because y times 1 is just equal to y. Now, if I'm going to use distributive property from this point, so we have 6x squared. We have 6x squared plus 6y squared times the quantity of 2x plus 2y y prime is equal to, using distributive property, we have 100x y prime plus 100y. Now, since there are y prime on the left side and the right hand side, then our goal there is to write it in one side only. Now, so we need to use a FOIL method on the left hand side. So we have the first term is 6x squared times 2x. We have 12x cubed. We have 12x cubed. And then outer terms, we have 6x squared times 2y y prime gives us the product of 12x squared y y prime. Then inner terms, I will write it clearly here. This is 2x. So 6y squared times 2x. So the product is 12x y squared plus the last term is 6y squared times 2y y prime. We have 12, 12y cubed and y prime. So we have 6 times 2 is 12, y squared times y, we have y cubed, and there's another one, which is y prime. So we have y prime there is equal to 100 x y prime plus 100 y. Now, we are going to write y prime in one side. So we have 12 x squared y prime plus 12y cubed y prime minus 100 x y prime equals, the remaining term is 100y, and the one that have no y prime here is 12x cubed. It becomes negative 12x cubed, and then we also have here as negative 12xy squared. So factoring out the y prime, so we have y prime on the left hand side. So we have to divide that one by y prime. So we have now 12x squared y plus 12y cubed minus 100x is equal to, we have 100 100y minus 12x cubed minus 12xy squared. So then to solve for y prime, so we have to divide both sides, whatever inside this quantity here on the left hand side. So I will just write here in the other side. So we have now y prime is equal to, we have the right hand side is 100y minus 12x cubed, 100y minus 12x cubed, and then the last term is negative 12xy squared. Negative, the last term is negative 12xy squared. Am I check? Yes. And then divided by this, by 12x squared y, we have the denominator of 12x squared y. The next term is plus 12y cubed plus 12y cubed. And the last term we have minus 100x. 100x. Okay? Or we can rearrange if you like. So if you're going to rearrange that one according to ascending order, we can write as negative 12x cubed minus 12xy squared plus 100y all over 12y cubed plus 12x squared y minus 100x. So either of the two is correct. Next, we have here, so given x squared plus y squared equals 25, find the d squared y over dx squared, which is actually the second derivative. So evaluate the first and second derivatives at the point negative 3, 4. So we have here, first we are going to take the dy over dx. So we have x squared plus y squared equals 25. Then take the derivative of that using implicit differentiation. So we have now 2x plus 2y, then y prime is equal to 0. So solving for y prime, so transpose the other terms, we have now 2y, y prime equals negative 2x, and y prime is equal to negative 2x over 2y. So y prime now is equal to negative x y, and this is what we call as dy over dx, because y prime is just equal to dy over dx. So I write there dy over dx is equal to negative x over y. So basically, these two are just the same. So that is now our first derivative. So since the first derivative, we have y prime is equal to negative x over y. So our x there, we know that x is negative 3 according to the given, and y is equivalent to 4. So by substitution, we have y prime equals negative x over y. So the negative of negative 3, which is the value of x, over y is 4. So we have now the first derivative, the value of the first derivative now gives us the answer of 3/4. So 3/4 is the answer of the first derivative. Now, if we are going to evaluate as well the second derivatives, so we can write here now as, so from the first derivative of dy over dx is equal to the negative of x over y. Now taking the derivative of that, d over dx of dy over dx is equal to d over dx of negative of x over y. So I am just showing you here that we are taking the derivative in order for you to see what happened, that it becomes d squared, because d times dy, it gives us d squared y, and dx over d times dx, they are the same. So we just write here dx squared. No need to enclose the dx. All right. And then this is now to take the derivative of that. So I have negative sign outside, let's factor out. And then we're gonna use the quotient rule. So we have VDU, we have Y times the derivative of X is 1 minus the UDV, we have X times derivative of Y is 1, but this is implicit differentiation. So the derivative of Y now becomes Y prime all over Y squared. So we have negative is the outside the outside sign. So we can write here. We have simplified that one. Y times 1 is Y minus x y prime all over y squared. But we know the meaning of y prime. So the meaning of y prime is negative xy. So by substitution to that, we have the negative of y minus x times negative x over y all over y squared. So the continuation will be here. So I have the negative times the quantity of y minus negative x times negative xy becomes now positive. So positive x squared over y all over y squared. And then if I have now to simplify that one, I have negative outside. So times we have y squared plus if okay, let's do like this step by step. So we have the LCD of the numerator is y. So y times y is y squared plus y divided by y is 1 times x squared is we have x squared all over y squared. So simplifying this one, it gives us negative times the quantity of y squared plus x squared all over y to the third power. So by substitution, we know that the given point is negative 3, 4. We know that the value of x is negative 3 and the value of y is 4. So the negative of so we have y squared is 4 is the value of y, so squared, plus x is negative 3, so negative 3 squared over 4 to the third power. So we have the negative of 4 squared is 16 plus negative 3 squared is 9 over 64. So 4 to the third power is 64. So 16 plus 9 is 25. So therefore, the final answer is negative 25 over 64. The negative affects it here. So the simplification of the numerator is 16 plus 9 is positive 25, but we have negative outside, so I multiply it now. So the answer is negative 25 over 64. So this is the value of the second derivative. So I will write it here as d d squared y over dx squared. That's the answer. Next problem, we are asked to find the tangent line to the graph given by x squared times x squared plus y squared equals y squared at the point square root of 2 over 2 for the value of x, and for the value of y is also square root of 2 over 2. So now let's take a derivative of the given equation of the line. So we have x squared times x squared plus y squared is equal to y squared. So if I'm going to use a product rule, or you can also use here a distributive property if we want. So I guess it would be easier if you're going to multiply it first. So let's multiply. So this is now x to the fourth power plus we have x squared y squared is equal to y squared. Okay, I use distributive property instead of using the product rule. But if you want, you can also use the product rule. Now, x to the fourth power is the first term, and x squared times y squared, we have x squared, y squared equals y squared. So taking the derivative now, we have 4x cubed plus, using product rule here in the second term, we have x squared, y squared. So we have x squared times the derivative of y squared is 2y y prime plus, that is our UDV, then VDU, we have y squared times derivative of u is 2x is equal to 2y y prime. The derivative of y squared is 2y y prime. Now I will just multiply here the middle term and write the other terms. We have 4x cubed plus, we have 2x squared y prime plus y squared times 2x, we have 2xy squared equals 2y y prime. Now I will group together having y prime and the rest will transfer to the right hand side. So we can write now as y prime. I factor right away. So we have here 2x squared y, and this one will be transposed. So we have minus 2y is equal to, transpose the other terms that have no y prime. So we have negative 4x cubed and minus 2xy squared. Now divide both sides by this quantity of 2x squared y minus 2y. So we can write now y prime equals negative 4x cubed minus 2xy squared all over 2x squared y minus 2y. Now, if we want to simplify it further, so we can use factoring if we want. So common factor here is negative 2x. So negative 2x is the common factor. So we have here the quotient when we divide now. So we have 2x squared, and negative 2xy squared divided by negative 2x, it gives us now positive y squared. Okay, we will check. Negative 2x times 2x squared is negative 4x cubed. That's correct. And negative 2x times y squared is negative 2x y squared. Also correct. Now the denominator, our common factor there is 2y. So I can write 2y. Then divide that one now from the denominator. So 2x squared y divided by 2y. So the canceled yung 2 and canceled yung y. So the remaining term now will be x squared minus 2y divided by 2y. We have here minus 1. So 2y times x squared is 2x squared y, and 2y times negative 1 is negative 2y. So very obvious that we can cancel the 2 and 2 here in the denominator. So we have now y prime is equal to the negative x times 2x squared plus y squared all over y times x squared minus 1. Okay? And since we are asked to find the tangent line to that given graph, so, and we are also given the point x and y, then we are going to substitute that one from the derivative. So the value of derivative now will be y prime equals, the value of x now is square root of 2, but you have a negative here. So I have negative square root of 2, square root of 2 over 2 times 2 times, I will use the bracket, times square root of 2 over over 2. This will be squared plus, y natin, y is square root of 2 over 2, and then this will be squared. Then all over y is also square root of 2 over 2 times square root of 2 over 2, and this will be, I will use bracket here, not apparent. Then this will be parenthesis squared minus 1. Okay, so maybe I can just write the answers on top. So we have here now y prime. So let us simplify. We can write here first negative square root of 2 over 2 and simplify inside the bracket. So this will be 2 times the square of 2 times the square of the square root of 2. All right. So this will be the square of the square root of 2 is just 2. But I have 2 here outside first. So we have 2. And then the square of the square root of 2 over 2 will be equal to 2 over 4 plus the same. Square root of this one is square. The square of the square root of 2 over 2 is equal to the numerator will just give us 2 and denominator will give us 4. So that's close all over. We have square root of 2 over 2 times the square root of 2 over 2 is 2 over 4 minus 1. Now let us simplify. Anyway, this one class, I forgot to simplify it a while ago, but that one is just equal to. So this one will be equal to negative 1. So I will just write it here now as negative 1, the result of this, the one that I highlighted here. So that's now negative 1. And then this will be 2 times 2 4. So we can use cancellation to that. That is now 2 over 2. Then 2 over 2 is 1. So that is now 1 plus 2 fourths or 1 half. So 1 plus 2 fourths is equal to 3 halves. So we have times 3 halves all over. Uh, I don't need anymore to write square root of 2 over 2 because I already reduced that one from I already divide that one from the coefficients of negative square root of 2 over 2. So what is now 2 fourths minus 1 or 1 half? 2 fourths minus 1 is just equal to 1 half. Or we could say 1 half minus 1 is just equal to negative 1 half. So we have here negative 1 half. Now, the final answer will give us, so dividing now negative 3 halves divided by negative 3 halves divided by negative 1 half. So it gives us now the answer of 3. So the final answer is equal to 3. Okay, so it's not yet the final answer. It is yet the slope of the line. So it is the slope of the line. So therefore, our slope is y prime is equal to 3, or we could say m is equal to 3. Now, we know that the given points is square root of 2 over 2, comma, square root of 2 over 2. That is the given point. Now, to write for the equation of the tangent line, we have y minus y1 is equal to m times x minus x sub 1. So, by substitution, we have y minus y1 is square root of 2 over 2, and m is 3 times x minus square root of 2 over 2. So, simplifying this one, we have y minus square root of 2 over 2 is equal to 3x minus we have 3 square root of 2 over 2. Now, if I'm going to eliminate the denominator of 2, so I can just multiply the entire equation by 2. So multiplying that one, it gives us now 2y minus 2 times square root of 2 over 2 is just equal to square root of 2, and 2 times 3x we have 6x, and 2 times negative 3 square root of 2 over 2, so cancel 2, so the remaining answer will be negative 3 square root of 2. And then rearranging that one, so I will just write here 6x minus 2y plus minus 3 square root of 2, and the negative 2 transpose becomes positive square root of 2 is equal to 0. So I am equating the equation in terms of equals to 0. And so therefore this can be 6x minus 2y, and negative 3 square root of 2 plus square root of 2 is negative 2 square root of 2 is equal to 0. So that will be now the final answer. Okay, so the final answer is 6x minus 2y minus 2 square root of 2. Then if you want to reduce it, since this is reducible by 2, so, or we could write the answer as, so divide it by 2, so the answer now is 3x minus y minus square root of 2 is equal to 0.